Hello there friends, welcome back to my YouTube channel Cloud with Mohsin. Friends, today we are going to cover a session with respect to automating AWS infrastructure with Terraform. This is infrastructure as a code for scalable cloud deployments. So before going with the discussion further, let me quickly take a moment and introduce myself. I'm Mohsin Sheikh. I'm 2 times AWS and 2 times Microsoft Azure certified professional with around 15 to 16 plus years of experience in IT along with the various domains. Okay, so that was quickly about me, and let's see which are the topics that we are going to cover today. So first of all, we will see an introduction to infrastructure as a code, that is in short called as IAC. Then what is Terraform. We will have an introduction to Terraform. Then we will also touch base why we should use Terraform with AWS and about its architecture as well as workflow. Then we will see setting up Terraform with AWS, and finally we will wrap up this session with a conclusion. So that is quickly about this session. Now without further ado, let's discuss about what is introduction to infrastructure as a code. Okay, so first of all, IAC is the process of managing and provisioning computing infrastructure through machine readable definitive files rather than physical hardware configuration or interactive configuration tools. So this is about the definition of IAC. If you are aware, we have some of the cloud native infrastructure as a code tools such as CloudFormation in AWS and Azure Resource Manager ARM templates in case of Microsoft Azure Cloud. So here the idea of using infrastructure as a code tools is we can write a code or script, and that will help us to deploy our resources in the AWS. So okay, let me just minimize this one. Yeah, sorry for that one. Okay, so that is about infrastructure as a code. Okay, so now what are the benefits of IAC? So first of all, there is a consistency. So it eliminates the configuration drift and ensures environments are identical. Okay, so in an example, you have multiple environments like production, development, QA or testing, and you are looking for same kind of configuration across the 3 environment. Okay, in that case, this is especially very much useful to use IAC code in such a cases. The next benefit is version control. So using infrastructure configuration, we can have a better control on versions, and we can track it in a better way. Then about automation, so it speeds up provisioning and reduces manual error. I will give you another example about automation. Normally when we are deploying the resources which are lesser in number, say few 5 or 10, so in that case we can do it manually. But consider in a scenario that you will need to deploy hundred or thousands of resources at one go. Okay, so it is not possible, rather I would say there will be some manual errors could be expected if we are doing it manually. So in that case we can consider Terraform or IAC infrastructure as a code as an automation tool. Okay, so here this PPT is mainly focusing Terraform infrastructure as a code tool, but as I mentioned, we have some of the cloud native tools as well, like CloudFormation for AWS and Azure Resource Manager ARM template in case of Azure, and we also have some of this services available in the Google Cloud, that is GCP. Okay, so that is quickly about to giving an overview of IAC. What is IAC? Now let's see what is Terraform. Terraform, as I said earlier, it is infrastructure as a code tool. It is an open source tool and it is developed by HashiCorp. Mainly it uses a declarative language. The language is called as HashiCorp configuration language, in short as HCL. Some of the key features of Terraform are, first of all, it provider agnostic. When we refer provider here, so it the significance of provider is the cloud service provider. Okay, so it supports multiple cloud providers and services. It is not, platform, it is not dependent to any particular cloud provider, and it's independent to the platform. Then about resource graph, so it builds a dependency graph of resources for efficient planning and execution. Then talking about state management, so it keeps track of resource states to map real world resources to your configuration. What does this mean? So Terraform has one file particularly that is called a TF state file. Okay, so that TF state file will record each of the resources that has been deployed by Terraform on that particular cloud platform. So using this, so it will maintain the state of that. Okay, so particularly it will keep the track of that. And in case suppose the Terraform TF state file, let me give you another example of state management. Suppose we have deployed an EC2 instance using Terraform, and it has been recorded in the TF state file. But if actually on the console or manual way, if we stop it, so there will be some conflict, like there will be a discrepancy between actually running state, the running state in TF state file, and the actually stop state. In that case, when we will initiate Terraform again, it will see that it is not matching the state in the TF state file, and it will go ahead and initiate or start that instance to be on the same page, that it should be on the running state as per the Terraform TF state file. So that is about the state management. Now there will be several questions why we should Terraform with AWS, as there could be cloud native tools as well that we can go for, or what are the benefits or features mainly. Okay, first of all, cloud strategy, multi-cloud strategy. We can manage AWS along with other cloud providers from a single tool. Okay, in a scenario when we have, like normally there are there's a multi-cloud scenario in most of the companies are they are going with. So there could be some applications running on AWS, some could be on Azure, some GCP, or there could be other applications in the other cloud providers. So that is called as a multi-cloud provider. The benefit of this is it ensures the vendor locking is no more. So that is the main advantage, and we can save some costs. So companies can save some cost if they can go for the multi-cloud architecture. Automation and efficiency is another feature you could say. So we can automate complex infrastructure provisioning with reusable code. We can use the same code. The code in the Terraform is basically code that we uses, and that can be used several times. So there is no limitation the number of the counts up to which the code can be used. So we can use it for the multiple times. Consistent workflow, same workflow for every provider, simplifying cross-team collaboration. What does this mean is, regardless of the platform, the workflow, that the set of commands that we will be using will be the same, regardless it is AWS or Azure or GCP or Oracle or some other clouds. So there is no differences between the set of commands, and this helps to simplify the cross-team collaboration. Okay, then another feature why we should use Terraform with AWS is community modules. Like we can leverage a vast ecosystem of modules for common infrastructure patterns. Okay, so these are some of the the points we can consider for using Terraform with AWS. Now let's touch base upon Terraform architecture and workflow. Mainly the architecture has the main components as configuration files and state files. Okay, a configuration file is something that it is written in HCL, that is HashiCorp configuration language, and it is defining the desired infrastructure. Here you can see a screenshot. Here it has been mentioned the provider AWS. So This is the important file. Suppose we need to deploy some resources on AWS cloud, then we can provide this in the configuration file, say configuration conf.tf, something like that. Inside it should have these main things, like what is the provider, region, so this will be where the resources will be deployed, and version. Okay, so these are some of the things we should have in the configuration file. In case of Azure, we will simply replace AWS with Azure, or in case of Google, we can use the same configuration file and replace the AWS by Google. Okay, so you can make the changes. So this is about the configuration file. About state file, as we discussed in the state management benefit, it maintains a mapping of real resources to configuration stored locally or remotely. So state file is that the file name, the tf state. It will be auto created by Terraform whenever we are deploying the resources. It can be either locally, that is on our laptop, or we can store it remotely somewhere. Okay, remotely, but it has it maintains the mapping of the real resources, and it gets auto created. So even if you delete the tf state file, it will auto create. Basically it will see the difference between the current state and desired state. The desired state means the resources that we are going to deploy, it will match, and based on that it will auto create even if we have deleted the tf state file. About Terraform workflow, so basically the workflow are the steps that we can follow in order to deploy the resources. It has got mainly 4 commands. Here I have not included init, so Terraform init will be the first command. After that would be plan, then apply, and finally it will be destroy. So when we go for Terraform init, it will initialize the resources. It will make the Terraform ready for the next deployments. Okay, plan will be, actually it is kind of preview. It will not do any changes, but it will give a preview that what are the resources that will be created or changed when we run the Terraform plan command. Then apply command will be, actually this is the important main command here. When we run Terraform apply, it will execute the plan changes. Okay, so the difference between plan and apply is, plan will just show you, okay, this will be, these are the resources. I'll give you an example. If you want to create say S3 buckets, okay, 5 S3 bucket, and you have your file ready, so along with the configuration file, and there should be one resource specific file, say for example s3.tf. Let me give an example. In that s3.tf you have provided what S3 bucket name it should be, okay, and all those things you will specify. And when you run Terraform plan, it will just show you, okay, after running this file, it will first of all examine if the syntax is correct, and if there is some syntax issue, it will just notify, we can correct that. Then after that it will tell, once we run the Terraform apply command, okay, that these are the resources that can be created, okay, based on this config. So basically it is a kind of preview. When we run apply, it will actually deploy those resources. Okay, and in apply there is a one phase. It will ask for the confirmation whether we can proceed with the current deployment or we should abort it. Okay, if we don't want that notification, we can automate that. We can provide the auto approval, but if that is not provided, then it will ask us before deploying the resources. About destroy, it will destroy all the resources when we simply run plain vanilla like Terraform destroy. And in case we don't want all the resources to be removed which we have created via Terraform, and we expect only few resources should be deleted, in that case we can specify Terraform destroy and the target which are the specific resources that needs to be destroyed. That can be specified along with this command. That should be subset of this one. So that is about the workflow. Now how to set up the Terraform with AWS. Some prerequisites before we can proceed with setting up the Terraform with AWS are: first of all, we need AWS account with appropriate permission. Then AWS CLI installed and configured. So if you have not watched, or if you are not aware how to install and configure CLI, that is command line interface, you can watch my previous video. I will just share the link in the description. So we can install and configure. Basically, in the configuration, it is mainly looking for access key ID and secret access key, so that it can do the handshake with our AWS account, and then we can deploy the resources to that specific account to which the handshake has been done by Terraform. Okay, Terraform install on your laptop or machine. Here you may ask me, okay, how to install the Terraform on our laptop or machine. So simply in Google you can go and type Terraform install. Here I'm using Windows 11 machine, so I have typed Windows. Okay, but simply you can type Terraform install. It will bring you to the HashiCorp website. You can open the first one. Let me open this one. And here, based on the operating system, you can see on my left we have operating system based on Mac, Windows, Linux, FreeBSD, OpenBSD and Solaris. Okay, as I need to install on my Windows laptop, I will go ahead and choose Windows. Based on the architecture of the system, either 386 or AMD, I can click on download this button and install. It is pretty straightforward. Similarly, if you are using Mac, you have these options. For Linux, these are the options. Okay, and similarly for operating system. So based on the OS, you can choose the installer and download and install it. In that case, it will be it is a binary that you can install. Here you can see the version, the most recent version that I can see is 1.10.5. so it will be installed on the machine. Okay, so that you can do. So this is one of the prerequisite. Yes, we discuss about Terraform install. How to configure AWS credentials. So about configuring AWS credentials, we need to use access key ID or secret access key. Okay, or IAM roles for authentication. And as a best practice, we should use IAM roles and temporary credentials when possible, because when we are entering access key ID and secret access key, it will be recorded under one of the folder in the path on the operating system, and that could be a security breach, or maybe someone with the bad intention can that person can retrieve those values easily. So as a best practice, we should use IAM role instead of providing the credentials. Okay, yeah, so we are at the end of this discussion. Let's just conclude what we discussed, or what are the key takeaways from this session. So Terraform simplifies and automates AWS infrastructure management. Embracing IAC, that infrastructure as code, leads to more reliable, repeatable and scalable deployments. Okay, so probably on the upcoming session we will go further and we will install Terraform. Then we will start to deploy some of the resources on the AWS. Maybe we can go step by step. So believe me, Terraform is very deep. We can provide as many variables of various resources, and that it's a very deep. So I would request you, please explore it. It is very powerful and very good tool that you can use and make your life easy when you are especially working on the the cloud providers like AWS or Azure or GCP or be it, because as it is cloud agnostic. Okay, so friends, that's it for today. I hope this session had put some value to your learning today. I really appreciate being with me, and thank you so much for your time, friends, and let's meet with another session where we will do the hands-on. Okay, so let's meet soon on the next session. Thank you so much and take care. Bye bye.